Lo que tú haces, cuando tú me pones la perspectiva, cambias y vas a estar. Ya no estoy pensando cuándo es, sino cuándo es cool. Es
Hi everyone. Hello. Good morning, good afternoon, good evening. So welcome to this session today, the Power BI session. We'll be discussing data modeling in Power BI. So I believe we're all data analysts. So as a data analyst, you should know what Power BI is, and you should know its usefulness in analysis. And then Power BI is encompassing of many functionalities. In Power BI, you have the Power Query functionality. We have the data visualization functionality, which allows you to build visuals, build dashboards, and all of that. We also have the table view, where you can view your table and then make modifications to your table, create new tables, create new columns, create measures. There are so many possibilities with Power BI, and then there's also data modeling. Now, if you've used SQL before, if you've worked with SQL before, you know that data modeling in Power BI is to joins in SQL. I don't know if I'm making sense. Power BI, data modeling in Power BI is to joins in SQL. So what join is to SQL is what data modeling is to Power BI. So what is data modeling? As a data analyst, also, I assume you've heard the phrase or the word, the sentence, or the two words data modeling countless times. In machine learning, you would come across data modeling. And then there's also data modeling in Power BI. But these two concepts, they are different. Their functionalities are different. So data modeling in Power BI is different from data modeling in machine learning. For those of you into machine learning, the concepts are way different. So data modeling in Power BI is a functionality that allows you to create or build relationships between your data. Building this relationship allows you to extract meaningful insights from your data where you have more than one table in your desktop, more than one table imported into your Power BI desktop. So I'm about to share my screen. You can see what we have. So just before we start, I would like to create a background or give you an insight into what data modeling actually is. So data modeling is the process of designing the structure of data that will be used for analysis and reporting, specifically in Power BI. So it includes defining relationship between tables, creating calculated columns, measures, and specifying data types and formatting. Now, we're going to be looking at how to create relationship and then things you need to have in mind before creating relationships in Power BI. Data modeling basically entails creating relationships between your data. As a data analyst, you would get to work with data from different sources. If you know how to bring in your data into your Power BI desktop, you would know that you have the option of bringing in as many data, as much tables as you want as possible. And you also have the opportunity of bringing in these tables from different sources. Now, when you look at this get data option, you can see the various different sources where you can bring in data from. And it doesn't stop here. When you click on more, you still see other options that allow you to bring in your data into your Power BI desktop for analysis, for cleaning, for visualization, and everything you plan to do with your data. So now what happens when you bring in data from different sources? Will you go straight ahead to start analysis, or will you just dive into creating visuals? The answer is no. Because if you make that mistake of going straight to analyze your data or visualize your data once you've imported this data from different sources, you would get a misleading result. Your analysis will be misleading. Your report will be misleading. Everything coming from your desktop will be misleading. Why? Because you didn't create a relationship between your data, between the tables in your desktop, your Power BI desktop. By Power BI desktop, I mean the whole Power BI architecture. That's Power BI desktop. Now, assuming we have data coming from Excel, we have data coming from SQL Server, we have the data coming from Azure SQL Server database, we have data coming from, let's say, over 5 different sources, right? And then all these data belong to one company. And all these data that we've imported, all these tables we've imported, they are related, they are similar. Take, for instance, employer, you are working on the employees' data of a company. And then in one table, you have the employee details. Employee details, you have on another table, employee address. On the other one, you have employee contact details. On the other one, you have employee salary details. Just different tables that are related. And then what is relating them? The fact that they are all employee, they all talk about employee, they're all pointing to the fact that, okay, this table, this whole table, everything we have here, it's relating to employee details. Now, once you brought in that data into your Power BI desktop, once you brought in the data into your Power BI desktop, all these different data. When I talk about data, I'm mention table. If you hear me mentioning table and mentioning data, I'm referring to the same thing. So your table is also your data. Your data is your table. Your data contains rows and columns. Your table also contains rows and columns. So don't get confused when I say data here, and then in the next instance, I'm mentioning table. So now when you brought in your table into your Power BI desktop, the first thing you're going to consider doing is building a relationship amongst your tables. You're going to consider building a relationship amongst your tables. That way you can pick an information from this table and get the corresponding value or the corresponding answers from the other table. That's the essence of building relationships. Now we'll go back to the instance with SQL. With SQL, if you have 2 different tables or 3 different tables, and you want to take, let's say you have customers, you have a customers table highlighting the customer name, the customer address, and everything. And then you have another table highlighting customer order details, basically order details. Now, you want to pick the customer name from this table, and you want to pick the order details from the other table. You're going to have to join these 2 tables for you to be able to get these 2 information you need. Because one information you need is on one table, another information is on another table. If you don't join these 2 tables together, you cannot extract your information. And same thing applies to data modeling. Same thing applies to how Power BI functions. If you go ahead to try extracting the data without creating the relationship, you would get a skewed result, a misleading result. So that's totally unadvisable. Now, I'm going to show you I've already imported 3 data sets into this Power BI desktop. And then we're going to assume that these 3 data sets came in from 3 different sources. This is a cookies company data. So in the first table, we can see the customers. We have the customers table, we have the orders table, we have the cookie types table. Each table have their own columns. They all have their own fields and what each field stands for. So for the customer table, you can see the customer table contains address, city, country, customer ID, name, notes, phone, state, and zip code. Now, the order table contains costs, customer ID, dates, order ID, products, revenue, and units sold. And then the third table, that's the cookie types table, contains the cookie type, the cost per cookie, the revenue per cookie, and units sold as well. Looking at these three tables, we can go ahead and try to get the units sold or the revenue generated by each customer. Let's try doing that without actually building a relationship between these three tables. Now, we want to get, this is the customer table, and then this is the customer name column. We want to get the corresponding revenue generated per customer. And we want to do it without building an actual relationship between these tables. So we can see whether we are going to get a valid result or invalid result. So I'll go back to my report view. And then I'm going to be using a table visual but just before that, let me show you what the values in the tables look like. Now, this is the cookies type table. The cookies type contains the information about the cookies type, the units sold per cookie type, the revenue generated per unit sold, and the cost of producing each unit. Then for the customers table, we have the customer ID, we have the name, we have the customer phone, we have the address, city, state, zip code, country, and notes. That's all. And then for the order table, we have the customer ID, the order ID, the products, the units sold, dates, revenue, and cost. So now we've not created any relationship. We're going ahead to see if we can get, okay, we're going to get the customer name and then try to get the revenue generated. The revenue column is in another table. So let's see if we're going to get a valid result. So for this, now I'm going to add the columns I'm going to add. We'll have for the customers, I'm going to add name. These are the customer names. And then I'm also going to add under the order table, I'm going to add revenue. So we have this. In case you can't see this. Let me increase the size. Okay. So as you can see now, we've analyzed the data. We got the customer name. This is like the store name or the customer name from one table, and then got the corresponding revenue from another table. Now I want you to look at this table and then share your observations with me. What do you observe from this table, what we have here? Do you think this result or this output is valid? You can raise up your hand or you can use the chat box to share your thoughts. I'm expecting your responses. Can you all see my screen? Please keep the response, keep your answers coming. Do you think this answer is valid? Do you think our result is valid? Because we try to get the sum of revenue by customer name. So we have our customer names here, and then we have our revenue here, the revenue per customer. Do you think this analysis is valid? Is it correct? Keep your answers coming. If you think it is invalid, if you think it is wrong, state why you think it is wrong. And if you think it is correct, also tell me why you think it is correct. Okay, someone said, the revenue is wrong. Someone said, no, it is not. Someone said it is not wrong. Victoria, can you tell us why it is not wrong? Deborah said the revenue is wrong. Why do you think it is wrong? I don't think it's correct. If you feel like it is not correct, tell us why you feel like it is not correct. We're all learning. There is an error. They can't have the same revenue, okay? No, please, it's not. It's not valid. It's not. Definitely not. It's not valid because it will be different for all to have. It will be difficult for all to have same revenue, okay? What if they all actually have the same revenue? What if on a normal, like what if the company or the different customers generated the same revenue? Just what if? Keep your answers coming. It's not valid. We have the same total for each product and the revenue. Someone just made a point. We have the same total for each product and the revenue. Thank you, Bikunolua. It is not valid since all have the same sum, right? They all have the same value and the column says sum, but the total gives the same value. You have a point. I think it is wrong because all have the same revenue, okay? I mean, it is not correct. I feel it is not okay. Victoria has sent in her answer. I mean, it is not correct. I feel it is not giving us accurate breakdown of the revenue for each customer. The sum of the revenue is also not right. What if it's actually a 9 to 10%? I don't understand that one. Emmanuel, what are you trying to say? So now, we've gotten our results, and obviously this is very wrong. The answers we have here, they are very wrong, because how do you have this revenue and then still come to the total row and you still have the same thing? It doesn't make any sense. And that's why I'm hinting on the fact that if you don't model your data, if you don't build that relationship between your data, when you have multiple data that are related and you're expecting to get values across these tables, if you don't create a relationship amongst them, you would get answers quite all right. But if you don't look twice, you would not know that the answer you're getting is wrong and misleading. So if you're bringing in data even from the same source and then the tables are related, create relationships between this data before you start your analysis. It's very important. So now that we have this, there's a message. Yes, the recording will be made available. So now, this is what we have. Now we're going to go back to our model view and see if we can create a relationship between this table and see if what will happen next. So for this now, just watch what I'm going to do. I'm going to explain everything that's happening now. So I'm going to create a relationship between these two here. I want to create a relationship across the tables. We have 3 tables. So I'm trying to create a relationship between these two. So the relationship has been created. I will do the same for this column, these two. Now, remember the answer, the insights we got before now. I'm going to go back to the report view and see what we have there. I didn't refresh anything here. Now, creating a relationship between these tables have actually returned the result we expected to get. I hope you all can see this. See the difference now. Without creating a relationship, we had the same values. Even in the total, we still had the same value across here, repeated here. And now that we've created a relationship, our result, the desired output is here. It's presented before us. So now I'm going back to the report here. I'm going to delete this. I'm going to delete the relationships. Yeah. So now, how many of you have heard of primary keys and foreign keys? If you've heard of primary keys and foreign keys, please specify in the chat box. If you've heard of primary keys and foreign keys, specify. If you've not heard of primary keys and foreign keys, also specify. Keep your answers coming. If someone raised the hand, you want to hear what this person wants to say? Who was raising a hand? I can't find you anymore. So keep your answers coming. If someone said this is their first time of hearing about it, yes, we have plenty yes here. And then no, some persons have not heard about it before. Okay. So now primary key. A primary key is a column. A primary key is a column. When you have a table and you have a column, like this table, let's use this table as for an instance. We have this table now, we have this customer ID column. Now, a primary key column contains unique values. Unique values corresponding to every entry in that table. Unique values. By unique values, I mean when we have 1, 2, 3, 200 or any end or any endpoints, 1, 2, 3 to any endpoints, that one there must not be repeated. 2 must not be repeated. So when you are looking up your table and you want to see who customer ID 1 is, you're not going to see 2 persons, you're going to see just 1 person. Same thing applies to foreign key ID. So on the other hand, a foreign key is a column. A foreign key column is a column that also contains the values in the primary key column. But this time, the values can be duplicated, the values can be repeated, the values can appear in more than one row. And the foreign keys are there to reference the primary key columns. The foreign key columns, they are there to reference the primary key columns. Now I'm going to show you something. I'm going to go back to our table to see what our table looks like. Now, in the customer table, you can see the customer ID column. You can see the customer ID column. We have customer ID 1. And the customer with customer ID 1 is Trust Vicious. The one with customer ID 2 is ABC Groceries, and so on and so forth. You can see there isn't any customer ID repeated here. So this is our primary key column. This is a primary key column because the values they are unique. They are unique and continuous. So aside having them as numbers, you can have them as alphabets, but we have just 26 alphabets. So if you're creating a primary key column with alphabets in there, that means you're going to have just 26 rows because we have 26 alphabets. You're not expected to duplicate any alphabet unless you want to change that column to a foreign key column. Now take a look at this other table. You can see customer ID. We have 3 repeated. And this is because a customer now, the customer with customer ID 3. The customer with customer ID 3 can purchase multiple orders. And that's what we are seeing here. The customer now purchased an order with this ID, purchased another order with this ID. Basically, the customer purchased chocolate chip, different units on different dates. So in this case now, the customer ID column is a foreign key column, whereas what we have here is a primary key column because it is not duplicated in any way. So that's that. Has anyone heard about fact table and dimension tables? Still use the chat box. If you've heard about fact table and dimension tables, yes. If you've not heard, no. Yes, no. I need more answers. Okay, I think the majority of us here have not heard of fact table. Yeah, the question is, have you heard of fact table and dimension tables? So now, fact table. A fact table is a table in your data model. It contains basically contains numerical values, but then you can find categorical. It's not contains numerical columns, but you can find categorical columns. Contains dates, and then those foreign key columns. It contains the foreign key columns, numerical columns, dates, and sometimes you find categorical columns in your facts table. Now, your dimension table, on the other hand, they provide the details. They're more like provide descriptions. They give descriptions to the columns present in the other table. They provide more details into the columns present in the facts table. So facts tables and dimension tables, there are 2 important types of tables in Power BI data modeling. A fact table is one that contains the primary measures or facts of the data model. What we are seeing here, they are all facts. So this is a fact table. We can see the foreign key columns, the order ID, the customer ID. These are foreign key columns. We have the dates column, we have these numerical columns, and then this one is a categorical column, the product column. So now looking at the columns contained in it, you can easily come to the conclusion that, okay, this is our fact table. And then looking at this cookies type table now, cookies type table, because the columns contained in this cookies type table provide details into this column, this product column here. And because the columns here provide details, it provides details into this particular column here. This is why this is our facts table. And then this is our dimension table. What we have here is also called dimension table. So fact table contains the primary measure of facts of the data model. The data in a fact table is typically numeric and can be aggregated. So examples of columns you will find in your fact table are sales column, revenue, order quantity, we have units sold, we have cost, and the rest of them. The facts table is usually the largest table in the data model, and it is often linked to multiple dimension tables. So it is this facts table now. This facts table now can easily be linked to the dimension table. These two can be easily linked to this dimension table because now we have a customer ID column. Customer ID column now is telling us that we have a customer table. We have a customer table. And with this customer ID column, we can easily create a relationship between this orders table containing numerical values, numerical entities, and then the customer table. And that way we can get more meaning into details about the customers and the values we have here, like the revenue, the units sold, the cost, and all of that. Same thing with this. But before we continue, I want to show us something. Now, in case you are confused, the cookies type table, we have cookie type. Under the cookies type table, we have the cookie type column. And then under the order, we have the products. So these two are the same. These two columns, they are the same. They have the same values in daring. So they are the same, except for the fact that the column names are different. So we'll go back to this. That's why we're able to create a relationship between product and cookie type. So now this product now is basically telling us cookies type. And then with this column now, if we create a relationship between this and this, we're able to get more information into the cost per cookie, revenue per cookie, and units sold. That's what defines the dimension table. And the ability to link this to these dimension tables via columns, via special columns or columns that are common between them gives rise to this facts table that we have here. So dimension table provide context and additional details about the data in the facts table. These are the data we have here. For the customer ID, we have a customer column. So we have a customer table. So this table now provide more context into this customer ID column here. For the cookies type table, everything we'll have here will provide more context into the products that we'll have represented here. Is it clear? Now, facts table contains foreign keys, whereas dimension table contains primary keys. If we look at the other table, we would notice that this customer ID table, the values in it, they are repeated. This products column too, the values in daring, they are repeated. But if we check this now, check the customer ID, it is not repeated. That's the primary, that shows that it is a primary key column here. And then if we check the cookie type, we can see that no cookie type is repeated. This is also a primary key column, something of that sort, because there is nothing repeated here. But in this case, we have the customer ID, the values are repeated. We have the products, the values are repeated. So let's go back and see the orders table so you understand better. Now this is the orders table. You can see the products. We have chocolate chip. We have chocolate chip. So when I scroll down, we will see other products, other cookie type, fortune cookie, they are repeated. That's why it's a foreign key column, if that's the case. And then we have the customer ID. So the IDs, they are repeated. But then if I go to the customer, the table bearing this customer ID, that's the customer's table itself. You can see the customer ID, they are not repeated. They are very unique. And if I go to the cookie type table, the cookie type, they are not repeated, very unique, unlike what we have in the other table. So put it somewhere in your mind. Facts table contains foreign key columns, whereas the dimension tables contain the primary key columns. It's that simple, plain and direct, straight to the point. Is it clear? If you have any question, use the chat box so we can attend to your question. So I can attend to your question before moving forward. Is it clear? We've not gotten to the part of creating relationship. Be patient. If you have any question, you ask. From what we've done so far, if you have any question, please ask. Now, there's no relationship between our table. If you know about measures, I'm going to create a measure now. I'm trying to illustrate something. I'm going to create a measure. I'm going to create a measure in this column for the revenue column. So I will try to get the sum of revenue. I'll create a measure and see if that measure can be applied to this. So we can get the sum of revenue by customer name. So I would go back to the report view. Let me adjust this a little. Just push this aside. So for the measure, I'm going to create, like I said, I'm going to create a new measure. Hold on. Now there's a problem. I can't view my data from this end. I'm supposed to be able to view it. For Power BI with it up and down, that's really a problem. So let me see if quick measure will work. Because to create a measure, it has to show. It has to show. Can't view my table from this end. Let me see if it's possible to create a quick measure. Okay, so it's sum of revenue. I'm trying to get some. Let me use addition. Okay, so for the order table, I'm going to use the cost because the costs and the profits. The cost column, okay, there's a measure here already. So I'm going to use the cost. I'm going to try to add the cost and the profit to give me the sum of revenue as a measure. The goal is to create a measure, but I can't view my data view. I can't find it here. Power BI with it up and down. So I'm trying to improvise. So I'm going to try to add this, the cost and then the profit. The sum of these two will give us the revenue. So I'm going to get my profits and then add. I want to believe it has been created. Collapse. I want to believe it has been created. Okay, we're not treating measures today. Measure is a quick calculation. It's more like, since we have this table, this order table. Since we have this order table, yeah. Since we have this order table, I wanted to create a measure that would give us the sum of revenue. This revenue column. I wanted to get the sum of revenue, right? And then when I get the sum of revenue, because this revenue is in the order table, I want to see now if that sum of revenue can be used to get the revenue by customer name in another column, because we've not created the relationship yet. So I want to see if it is possible to get the sum of revenue by customer name, which is in another column, when we've not created a relationship. Now, those measures I created, see where they entered. Let's see if I can create one here, new measure. So yeah, I can create one here. So total revenue. So our total revenue will be sum of our revenue column. Our revenue is under the order table. I have this revenue. I'm going to close this bracket and hit enter. So now the measure has been created. I have total revenue here. Now, when I try to see the total revenue, let me use the table visual. So this, we want to see our total, the overall revenue. By overall revenue, what we mean is the sum of everything on this column, the revenue column. So we've calculated it already using this measure. So it is already there. So let's view the value. Can use that table visual. So I'm going to add data, go to the orders column, and then total revenue. So you can see this is our total revenue, 4.69 million. That's the total revenue generated by this company. Now, I want to see the total revenue by customer name. Customer name is in another column, in another table rather. So I want to see, we've not created a relationship yet. There's no relationship between our tables. So I want to see, since the orders table has the total revenue, is it possible for us to get the total revenue by customer name? Is it possible? Because there's no relationship. I'm just trying to make the whole concept clearer to you all. So I would bring a table visual again, and then drop in the customer name that's under the customer table. I'm going to drop in the name, and then I will drop in the total revenue. As you can see, share your observation in the chat box. Share your observation with me in the chat box. I think we got our results. Am I right? We got the result we want. Am I right? If we got it, say yes. If we didn't get it, say no and state your reason why this result is invalid. If you think we got our answer, if you think this output is right, is correct, say yes, and then state your reason why you think it is correct. If you think it is not correct, say no, and then why you think it is not correct. I'm expecting your answer so we can forge ahead. If someone said, I think it is correct. Kisembo, why do you think it is correct? I feel it is wrong. The total is the same thing with the breakdown. Can you tell us why you feel it is wrong? Okay, since it is wrong, we all agree it is wrong. So why is it wrong? Why is it wrong? Why is the result wrong? The output is wrong. So I want to know, why is it wrong? Matthew said, we have not created a relationship. Thank you very much. Thank you for following this class. Thank you, thank you, thank you. It is wrong as it is not giving us breakdown of the revenue. Yes, it is wrong because it's not, we'll know this fact. So why do you think it is this way? It's wrong. It includes only total revenue. It includes only total revenue. That's not feasible. Because once the total revenue by the customer name, like we did in this other table. So someone said there's no relationship between them. Very correct. Thank you. So is there any other answer, any other correct answer? Is there any other correct answer? The relationship has not been created. Correct. How do you create a relationship? Okay, so we're going back now. Now, this is what we have because we've not created the relationship. So I'm going back to do the right thing. What I did is wrong. It is wrong. Have it at the back of your mind. It is wrong. So I'm going to do the right thing now. I want to go and create the relationship now. Okay. So now to create the relationship, I'll look for a common column between this and this. And the common column is what? The customer ID column. So I'll drop this here. The common column between these two is the customer ID. So I'm going to create a relationship between them. So you just drag and drop. These two, the common column between these two is the product, like we saw before, the product and the cookie type. So we'll create a relationship. So as you can see, we have our relationship. So we can go back to that report and see the values have changed. We've gotten the correct answer. So connecting your data, creating relationship between your data, don't play with it. It is not hard. It is very easy. So just have this at the back of your mind. It is easy. You just need to know how to connect your dots. It is not difficult one bit. So now we've created that relationship. I want to explain to you why we did what we did. We have little time left because we're supposed to stop by 9. So I'm just going to rush things up. So now this one you're seeing here, and then this star means one-to-many relationship. We created a one-to-many relationship between these two. And then we created a many-to-one relationship between these two. Why? Because if you look at these two tables now, this is a customer table. Assume yourself as a customer, and this is the order table. One customer can have multiple orders. One customer can have multiple orders. That's why we have one. One customer can have multiple orders. And then here we have cookie types. A cookie type, one cookie type can be ordered many times, which is what we are seeing here. So I'm just giving you surface explanation so you understand what we are doing here. So there are cases where you see many-to-many relationship, that is star to star. What the star to star means is that you're creating a many-to-many relationship. But in that case, what it means is that for the table we are going to have here, we cannot create a star to star, a many-to-many relationship, because you can only have multiple orders for one cookie. You cannot have multiple orders for, you cannot have it the other way around. Like I said, one cookie can have multiple orders, but one order cannot have multiple cookies. So if you do many-to-many relationship here, which you would have star here, it means you're saying that multiple orders can have one cookie, and one cookie can have multiple orders, which is wrong. What we have is one cookie can have multiple orders. That's what we have with one-to-many. And in this case, one customer can have many orders. One customer can buy many cookies. One customer can buy multiple cookies. It is very feasible. But one order cannot have many customers. One order will surely have a customer, one customer. So a particular order with a particular ID cannot have two customers. You cannot have two customers having order with the same order ID. Does it make sense? So one-to-many relationship is the most common type of relationship in Power BI. So rarely or hardly will you see your data or your tables forming one-to-one relationship or many-to-many. In most cases, Power BI will even automatically detect these relationships for you. So you don't need to stress yourself. Just know what it means to create a relationship and the importance, and don't joke with it. And even when Power BI creates a relationship, it doesn't mean it is 100% correct. You still have to go through the relationship it has detected and be sure that, okay, this relationship is what it is supposed to be. Assuming Power BI decides to link customer ID to order ID, it is very wrong. And if you did not check it, you would go on with your analysis having customer ID joined to order ID. So you have to cross-check it and then be sure that what you have is correct. So like, I'm going to repeat another point. Your facts table contains foreign key columns. Your dimension tables contains primary key columns. So that's that with facts table, dimension table, primary key, foreign key. And then we've already modeled our tables. This is all we have. Is there any question? The recording will be posted on the group. Like I said, you have to check your tables and then know the type of table you have. Now, this is an order table. If you go to a restaurant to order food, you can order rice, you can order beans, you can order You can order beef sauce, right? You have 3 orders there. And if the restaurant places a number to these orders, to every order you make, let's say the rice is order number 1, the beans is order number 2, and then the beef sauce is order number 3. You as a customer, you have 3 orders. But then that beans ID, that rice with ID number 1 cannot have another customer because you've already ordered it. So it is possible for a customer to have multiple orders, but one order cannot have multiple customers. Mark this, just take note of what I just said and then try to think over it. It's possible for an order to have an order will have 1 customer, but a customer can have multiple orders. And that's why we have this thing. Customer has multiple orders. A customer has multiple orders. And then the same thing with the cookie. Cookie has multiple orders coming in from customers. I hope you learned something new today. This class is not for measure. When creating relationship, you consider the columns in the tables, and then now for these two, you look for the columns that are matching. It is not enough to have customer ID and customer ID. Go back to your table. You go back to your table, you check the customer ID for the order table, the customer ID, and then you check the customer ID for the customers table. Ensure that the values correspond. Assuming you have for this now, for the customer ID here, you have values ranging from 100 to 200. And then here you have values ranging from 1 to, let me say 1 to 5. You know there is no correlation, even though they have the same value. So you still have to check the values in these columns to be sure that, okay, customer ID is actually customer ID. And then here now we can see if we decided to compare these two based on just the column name, we'll miss out on this relationship. Why? Because we connected it to the product. The product is the same thing as the cookie type, but then the column names, they are not the same. So if we're just concerned about, okay, finding a column here that is also here, we would miss out on creating this relationship. We would miss out. But then because we've looked at our data set and we've noticed that product tallies with cookie type, we're able to reach that conclusion. And then when you are also doing this, ensure that in your facts table, what you have there is a foreign key column. And then in your dimension table, what you have there is a primary key column. Thank you. So maybe next week, I don't know, maybe next week we'll see what's up, but I would have to stop here. I really hope you all learned something. I really hope so. Yeah, you're welcome. So the recording will be shared in the group. So we'll be calling it a day here. Thank you all so much for joining me. My name is Promise Chinon. So in case you don't know who is speaking, it's actually Chinon. So it's me. So thank you all for joining me. The next tutor will be coming in. That's why I have to leave now. If it's that there's no other tutor, I would have loved to continue, but another tutor is coming in, so I have to leave. He's coming in by 9 to take Python. In case you're interested, go back to the group and then click on the Python link to join. See you all later. Bye.